All right, I did put up kind of, it's kind of a trick one, but if you pay attention yesterday, it won't be a trick. We're looking for sine inverse of -1/2, so we're trying to find -1/2 on our unit circle. Now, sine inverse only exists in quadrant 1 and quadrant 4, so we're looking at this angle right there, which if you very quickly look at my answers, you're going to go, hey, that's A. But it's not A, because that isn't part of it. 11 pi over 6 is not part of sine inverse 1/2. You have to go in the negative direction. So the correct answer should have been negative pi over 6, which is C. All right, can someone give me the arc cotangent of 1/2? What is the arc cotangent of 1/2? Mary? Ooh, has to be an angle.
Oh, sorry. I was thinking.
That's okay. Nope.
Never mind.
Anytime you see arc or you see that inverse symbol, you should think my answer has to be a negative sign. Because like I said, that's going to happen so many times to all of you. All of a sudden, you're going to forget that it results in an angle, and it's going to keep happening. Now's the time to make those mistakes. Next week on the test, not the time to make those mistakes. So someone want to help Mary out and tell me what the arc... Russ? It is pi over 3.
Yeah, I thought you were asking something else. I woke up like 45 minutes ago.
That's okay. Did you have the answer written down too?
Yeah.
Is that what
I thought you said something else. And I was like,
Oh, did I?
yeah, you did.
Oh.
Yeah, I was like, I don't know.
I don't know. We didn't learn that. All right. What is the arc sine of square root of 2 over 2? What is the arc sine of square root of 2 over 2, Priya? Pi over 4. I always like those square root of 2 over 2s because they always happen in those middle dot areas. All right, let's just go over questions from the homework that we can go into our lesson and hopefully just fly through it. As I tell you, stuff is unimportant. Bree, you said you already had questions.
Okay, for like 17
Gotcha.
or 28, when it's cosine, like the, what is that, inverse,
Mm-hmm.
it's not negative,
What's not negative? I'm sorry.
the answer.
The answer will not be negative.
Okay.
It won't be negative because... let me take a picture of it real quick. So number 17 looks like that jazz. Right? So we're looking at our unit circle. We're looking at our unit circle, drawing a perfect circle. Got it. Close enough. We are looking for things in quadrant 1 or 2. And all of those are going to be positive angles. It is between 0 and pi, all positive. So cosine inverse will always be a positive angle.
Oh, okay.
The only reason why sine is negative is because we get rid of that quadrant. That was a terrible idea because now we're going to erase stuff. We can't actually go through the positive. We have to stop here. So we have to go this direction, which is a negative angle.
Okay.
That's the reason why sine has a negative, because you can't go through here. This wall kind of stops it, so you have to go in the negative. Is that clear?
Mm-hmm.
Because I know you had that question yesterday. I just want to make sure that. All right, Mary.
In 21, I like to replace the answers. Like, I got 5 on that 180 for 18, and 21 I got 0. Like,
Okay, well, the cosine inverse of 1, so we just need to figure out where cosine equals 1. Well, cosines are x value, right?
yeah.
So right there is 1, so it should be 0. I think you just had them flipped. I think you had it as the 0.01,
Yeah.
and I think you just had those two values flipped.
Okay.
Other questions? Yeah, Russ. 10. 10 is arc sine of -1. It's arc sine of -1. So we're looking at, let me get my pointer. My sweet pointer stick. We'd be in quadrant 1 or 4, right? So I'm going to look at that -1 down here. It has to be this -1 down here. Now, it looks like it's at 3 pi over 2.
Yeah.
But that would mean that you went all the way through these quadrants, which you're not allowed to.
Okay.
You're not allowed to go past. So sine inverse goes from here down here, and nothing else exists.
So it can't touch the line.
So it can touch here, but instead of going around this way, you have to come down that direction, which is a negative angle.
Oh, okay,
So it's a negative pi over 2.
yeah. Okay. Thanks.
So real quick, so it looks something like pi over 2, right? And this would be a negative pi over 2. So when you're dealing with sine inverse, all of these will be negative. So this will be a negative pi over 6. This would be a negative pi over 4. This would be a negative pi over 3. And these would be all the positive versions of it. All right, so when dealing with sine inverse, you have to realize that it can be negative angles.
All right.
In fact, half of them are.
Yeah. Thanks.
Yeah. Other questions? Okay. Then let's go through the rest of our inverse functions. I'm going to tell you right now, I'm not going to hold you too responsible for being able to graph these. I just want you to be able to graph sine inverse and cosine inverse. Those are the two I expect you to be able to graph on like a test. These I don't expect you have to. Maybe it'd be like bonus points on a test, but it wouldn't be anything major. All right, so the inverse of a cosecant function. Now, if I'm graphing a cosecant function, the first thing you do is you graph a sine function, right? All right? Or am I wrong? I think I'm right. All right. So we'll graph a sine function really quick. Remember, the sine function is only to help us get our graph. So this would be 1. This would be negative 1. I'm going to go a little further on this one. I'm actually going to go down in the negative direction. Now, anywhere we're at 0 or we hit the sinusoidal axis, we do a vertical asymptote. So the vertical asymptote there. There's a vertical asymptote there. There's a vertical asymptote there. Now, our actual graph would look something like that. Once again, that does not pass the horizontal line test. So its inverse would not be a function. Once again, if you would use all of this, if you look at the unit circle, if I said, remember when I said, like, what is the sine inverse of negative square root of 2 over 2? If you use the entire unit circle, you'd have 2 possible answers. But if we condense it to quadrant 1 and 2, there was only one place that had the answer. Same thing here. Good news. Good news is cosecant is the reciprocal of sine. So we reduced it to the exact same quadrants. So we are going to reduce it to negative pi over 2 to pi over 2. So cosecant, let's go back to this. Our cosecant inverse has the same quadrants as our sine inverse. Is quadrant 1 and is quadrant 4. So if you just remember that cosine thing, then you'll know where cosecant is well, because it matches up with sine. All right, if I had to graph the inverse and I didn't know what it looked like, what I would do is I'd pick out points. So this is pi over 2, and that's 1, and I'd flip the x and y values. That's how you graph an inverse. You flip all of your x and y values. So this is pi over 2, 1. That is that point there. So that's pi over 2, 1. Flip them, and you're going to go 1 pi over 2. Now this graph will actually go like that. All right, then we'll do the same thing for this other point down here. That's negative pi over 2, negative 1. Flip those values to be negative 1, negative pi over 2. And this one's going to come up like that. Like I said, the graph of this would only be like extra credit. I put like an extra credit problem, graph, cosecant inverse. All right, let's go ahead and work through some problems on this because it's slightly different. Ooh, right here. Note that we're in quadrant 1 and 4. All right, so we have a little note here. It says, note cosecant of pi over 6 equals 1/2, and sine of pi over 2, or pi over 6 equals 2. Thus, cosecant of negative 1/2 equals sine inverse of 2. This is kind of like a crappy example, getting to this whole point, that cosecant inverse of x equals sine inverse of 1 over x, or the reciprocal of that value. And what I want us to do is I want us to put a note on the side. We're going to put a note. When I ask you to find the cosecant of an angle, say cosecant of x, I want you to think 1 over sine of x. Oh, I'm sorry, cosecant. And now that we're talking about cosecant inverse x, that is now going to equal sine inverse of reciprocal inside. So the way I think of this, I think inverse inside. So when we're doing regular cosecant, we'll see examples of this. Regular cosecant, you find your sine value and you flip it. It all happens on the outside. When we're doing the inverse, the reciprocal happens inside of the parentheses. Regular, do it outside. Inverse, you do it inside. An example of that would be here. I need to find the cosecant inverse of square root of 2. Now we don't have cosecant on our unit circle, so what we're going to do is we're going to turn this into sine inverse. And we'll do sine inverse of the reciprocal of square root of 2, which will be 1 over square root of 2. Well, that's also not on my unit circle, so I'm going to multiply the top and bottom by square root of 2. To get me to, I'm looking for the sine inverse of square root of 2 over 2. Nora.
Did you have us do that last night?
I did have you do that last night. I actually found this value. We just didn't start with cosecant.
Oh.
I gave you sine inverse of 1 over square root of 2. Just to prep you for today, that you might have to do that. Emma.
I have noted what you mean by inside versus outside. In the thing.
So we're taking the reciprocal inside. Let's say I ask for the cosecant of 2. So if I ask for the plain old cosecant of 2. No. Let's say I'm looking for the cosecant of pi over 2. That's not a good example. Pi over 4. If I'm looking for the cosecant of pi over 4, what I'm going to do is I'm going to find the sine of pi over 4, and then I'm going to take the reciprocal of that. So the sine of pi over 4 is square root of 2 over 2. So that would be 1 over square root of 2 over 2. And we take the reciprocal of that, and we have 2 over square root of 2. So I took the reciprocal of something that's not inside the parentheses. I actually found my sine value and then took the reciprocal of it. In these cases, I'm actually going to take what's inside the parentheses and take the reciprocal of it to turn it back to sine. So I just picture, if I'm looking for the inverse, I take the reciprocal inside. If I'm doing regular cosecant, I'm going to get that sign value, and then I'm going to take the reciprocal at the end. So in this one, it's the first step to take the reciprocal inside. For regular cosecant, you do it at the end. Ross.
So for those use like that you're doing right now,
Mm-hmm.
we do it inside the breath.
We're going to do inside the parentheses. Yep. That's why, like I said, I think inverse, do the reciprocal inside. The other method is you find that value and then you flip it at the very end. That is your last step. Let's do some more like this. So we have sine inverse of square root of 2 over 2, which is going to be pi over 4, because we just find square root of 2 over 2 on our unit circle. All right, our next one is supposed to find arc cosecant of 1. Well, once again, we're going to do the sine inverse, and we're going to take the reciprocal of 1, which is still 1 over 1, which is still 1. So we're just trying to find the sine inverse of 1. And what's the sine inverse of 1? Stop.
Is it one?
No, it should be an angle because it's a sine inverse. Nora?
Pi over 2.
Pi over 2? Positive?
Yes.
100%.
Yes.
Okay. Yes, Bree.
Why would it be 1 over pi over 2?
1 over pi over 2. So like I said, when we're doing inverses, you do the reciprocal inside. You don't take the reciprocal at the end. So when we're doing regular cosecant pi over 4, we find our sine value, and the last step is take the reciprocal. With inverses, you do your inverse, or you do your reciprocal inside. So this is 1 over 1. You flip it, it becomes 1 over 1, and whatever answer you get. So you only take the reciprocal once in both of these. So in this case, I took the reciprocal of square root of 2 because it was inside. As soon as you take your reciprocal, you're done taking reciprocals. This just happens on your first step. When you're dealing with regular cosecant, you do it on your last step. Okay? All right, let's look at the secant function. The secant function, what time is it? All right, our secant function. All right, secant is with cosine. That's a little aggressive. Cosine looks something like that. And we're going to take our vertical asymptotes, and wherever it crosses the... Why is that one so aggressive? There we go. I have a vertical asymptote there. I have a vertical asymptote there. Then when I do my actual graph, it'll look something like this, like that, and like that. And what we're going to restrict our domain to is that, which is the same restriction of our cosine inverse. So we're going to restrict to quadrant 1 and 2. And that will be my secant inverse, which is the same thing as my cosine inverse. Once again, that is 1 and quadrant 2. All right, the graph of this, we'll pick 2 points. Let's pick this one and flip their x and y values. This one is pi negative 1, so it'll be negative 1 pi. Negative 1 pi. Other one is 0, 1. So you flip it, it'll be 1, 0, which will be right here. This one's going to look like this. It's going to go like that. It's going to go like that.
Wait, where did you get the one?
Where did I get the what from? I'm sorry.
Like,
The 1, 0?
yeah.
I got it from this point here because it's 0, 1.
Oh,
Flip
okay.
those x and y values and it's 1,
Okay.
0. Mark.
Is pi over 2, or 0 pi over, yeah, is pi over 2 a horizontal asymptote?
Yep. So if you want to put that in there, you can.
At all?
What was that?
Does it like relate at all to anything?
Yeah, I mean, officially, yeah. These will never reach that pi over 2 because they never reached it here.
Oh.
I'm just not concerning ourselves too much with graphs right now. It's hard enough to tackle cosecant inverse and secant inverse without throwing a bunch of graphs at you. Because it's hard to understand why that inverse is happening inside versus outside this time. So I want you to focus on these values versus that graph. All right, so like I said, we are in quadrant 1 and 2, so that means all of our angles are going to be positive. I'm also going to put that note again. I want to say this as much as possible. So on that note, it says note secant inverse of x equals cosine inverse of 1 over x. So the reciprocal happens inside of the parentheses for inverses. Your reciprocal is going to happen inside. Little side note. Don't forget that if it's just regular secant of x, that would equal 1 over cosine x. Maybe we'll, just for the sake of this, maybe we'll put an example next to that. Let's say I'm looking for the secant of pi over 3. I'm going to look for 1 over cosine of pi over 3. And if we look at pi over 3 on a unit circle, the cosine is 1/2. So that would equal 1 over 1/2, which would equal 2. Note that the reciprocal happened at the very end. The last thing I did was I flipped that number. When we're doing inverse, it's actually the first step we're going to do is we're going to go ahead and flip it. So secant inverse of -2 will become cosine inverse of -1/2. That means we just find -1/2 on our unit circle, which is at 2 pi over 3. So this is going to be 2 pi over 3. Yeah.
So the secant and cosecant are only for the graphing? Like that only makes a difference for the graphing?
I'm sorry. I didn't quite get the question.
So basically secant is the same as cosine, right?
Yep.
Okay.
Yep. So anytime you see secant, you should think cosine. How does this affect my cosine? Well, if I'm doing regular secant, I just take the reciprocal at the end. And if it's inverse, then I do the reciprocal inside, and it's the first step I do. All right, arc secant is going to be the same thing as cosine inverse. We take the reciprocal inside, which should be 1 over 2. I just need to find where cosine equals 1 over 2 on our unit circle, and that's at pi over 3. So yeah, Ross, like you said, anytime you see cosecant, you want to see how I can say it in terms of sine. And anytime you see secant, you're going to say, how can I say this in terms of cosine? All right, inverse of our tangent function. Inverse of our tangent function. Let's remember what our tangent function looks like. Our tangent function has vertical asymptotes at -pi over 2 and pi over 2, and it goes up. Guess what? That already passes our horizontal line test. So we don't need to constrict it any further than just one cycle. But let's look at where we are. We are between -pi over 2 and pi over 2. So this is negative pi over 2. This is pi over 2. And tan inverse is somewhere between there. So it works just like sine. And there's going to be a little trick to remember that. We'll write a little thing, yeah, when we get down. Kind of like that cosine one. There's one that works for tangent. I can help you remember it.
Cotan.
It is going to be cotan. Quit rooting the surprises. Ugh, I'm done. Calling it. Mark, get up there.
Alright.
What happens to the like end of the?
It's right here.
Oh.
I was charging it. It died. Okay. Well, we have horizontal. This is pretty easy to do with your horizontal asymptotes. So if I have a vertical asymptote at negative pi over 2, we're going to have a horizontal at negative pi over 2. If we have one at pi over 2, we're going to have one at pi over 2 here as well. And the cool thing is, it's going up, so its reciprocal is also going to go up. It's just going to be kind of sideways. Because reciprocals are always flipped like that. Like I said, don't worry too much about the graph. If you want to, awesome. There could be an extra credit. I don't guarantee it. Haven't written the test yet. We'll see. All right. So that's in quadrant 1 and quadrant 4. Well, tan inverse should be on your unit circle. Or tangent should be on your unit circle. Is one of the things that I told you need to know for the test. So we're trying to find tan inverse of pi over 3. So I'm going to go ahead and get a unit circle up there that has it. Boom, boom, boom. Good enough. So I'm looking for where tangent equals square root of 3, somewhere between these values and these. Well, it's right there at pi over 3. So it's going to be pi over 3. Then I'm supposed to find the arc tangent of 1. So I just go between here and here and look for where tangent equals a positive 1. And it is right there, which is pi over 4. I can't stress it enough. You need to have those memorized. You need to have those memorized and be able to put that on a unit circle. All right, we just have one more to go through, and that is our cotangent. Yeah, sorry.
Wait, why does it say that it's in quadrant 3?
It doesn't. That's a 4.
Oh.
It's just not a very well written 4.
Oh, okay.
The V isn't quite Ving.
Okay.
Yep, it's quadrant 4. Good to ask. I always ask if my penmanship is so horrible you don't know what's going on. Because that's like 90% of this class. All right. Our cotangent. We have vertical asymptotes at 0. And at pi. And if tangent's always going up, our cotangent's going to always be going down. This is actually a problem for us. Because that's good. So we're between 0 and pi is going to be my cotangent. That's going to turn into a problem in a second. But let's just tackle the graph first. If I have a vertical asymptote at 0, the reciprocal is going to have a horizontal at 0. If the main graph has a vertical at pi, this is going to have a horizontal at pi. All right, and since it's going down, its reciprocal will also be going down. Bless you. Bless you. Bless you. Here's where we have a problem. Cosine inverse and secant inverse existed in the same 2 quadrants. Sine inverse and cosecant inverse both existed in the same quadrants. Here's where we're going to come up with a problem. And I'm going to focus on a specific problem before we go over these little cheat sheet things. Cotangent inverse of negative 1 over square root of 3. We are going to put this in tangent inverse land because that's on our unit circle. To convert it to tan inverse, I need to take the reciprocal inside, just like with cosecant and secant. I need to take the reciprocal inside, so I'm looking for the tan inverse of negative square root of 3. Let's look at our unit circle. Now remember, tan inverse is restricted to those two quadrants. Tan inverse of negative square root of 3 is 5 pi over 3. Does 5 pi over 3 exist for cotangent inverse? No, because cotangent inverse only exists in quadrant 1 and 2. It's not that big of a problem. You just have to be able to catch it. So tan inverse led me to 5 pi over 3, right? Which would actually be negative pi over 3. So since we're in tan inverse, we'd have to use negative pi over 3 because we're going that direction. Here are two shortcuts to remedy this. So we said cotangent inverse lives here, and tan inverse lives here. That's where that cotan comes in. Well, if tan inverse gets me to negative pi over 3, all I have to do is shoot straight across and write 2 pi over 3. I like that method. I like just finding the angle it is, shooting straight across, and that's your answer. The official method to doing this is if it's negative, add pi to it, which is just shooting it straight across. So because this is negative, we have to add pi to our final answer. And tan inverse of negative square root of 3 is going to be negative pi over 3 plus pi. Pi is actually 3 pi over 3. So this is just going to equal 2 pi over 3. Safa.
Why couldn't you just go right over to the negative square root of
You can do that too.
3 if you already know?
You can do that too.
Okay.
So Safa came up with another method too that I like to use. I'm like, well, I'm already dealing with cotangent inverse, so why not just find where if tan inverse existed at negative square root of 3, it'd be right here. Mary.
Sorry, how do you get from negative square root of 3 to negative 5 over 3 in the next step?
What did I do?
So like, from tan of to the negative first.
Of negative square root of 3.
Yeah.
So I just went on my unit circle, and I looked for where tangent equals negative square root of 3.
Oh, you just replaced.
I actually did the inverse. Yep,
Okay.
I did the inverse was negative pi over 3. So I think cotangent inverse is the hardest one when you have those negative angles. That is the hardest one to tackle because it puts you in the wrong quadrant. You have to either do what Safa did, where you just realize that cotangent only exists up there, so find where tangent equals negative square root of 3 up there, or find that, shoot straight across, or add pi to it when you are done. All right, if our cotangent is square root of 3, you're going to look for where tan inverse is 1 over square root of 3. I don't like having radicals in the denominator, so you'd multiply the top and bottom by square root of 3. And you'd end up with tan inverse of square root of 3 over 3. Well, the cool thing about that being positive is when I go back to my unit circle and I find square root of 3 over 3, cotangent and tan inverse both exist in that quadrant, so we can just do pi over 6. I'm going to highlight one of these. If you ever have cotangent inverse of pi over 2, it's just 0. Because that's where tangent's undefined. All right, really quick recap. Quick recap. If I have cosine or sine inverse, you're just going to write cosine, and you'll know what quadrant you're in. But that also works with secant inverse and cosecant inverse. So if I was taking this test, the very first thing I'd probably write on the top is cosine. Make sure I don't mess that up. For tangent and cotangent, you're just going to write cotangent to know what quadrant you're in. So none of your inverses use the quadrant 3. So if you're ever in quadrant 3, you made a major boo-boo. All right, I know it's not fun because it's a whole new schema. It's different. You're taking reciprocals in different places. My advice to you, do the homework. Then I would look back. So I would do this homework. And then I would look back at homeworks that had just regular secant and cosecant and practice those right away. Don't lose this skill by learning the new skill. All right, that is the hard part, is keeping these separate. Is keeping that when you see secant, you take the inverse at the end. If you see secant inverse, you take the reciprocal right away. It is the hardest part of these. All right, some people will get inverses correct, and they'll get the other ones incorrect. Some people will get regular secant correct, and they'll get the inverse incorrect. It just takes practice, and you need to know how strong you are at something or how weak you are. And that means these homeworks aren't that long. That's the whole point of them not being long, is because I want you to be able to go back and forth and study old material while you're doing this. All right. Any questions for me?